Hi everyone. Today let's try to solve another problem on projections of lines. It's the third problem we have. The question is like this. A line AB has its end A 20 mm above the HP and 30 mm in front of the VP. The other end B is 60 mm above the HP. The distance between the end projector is 70 mm. Draw its projections. Determine true length and apparent inclinations. Here we'll draw it on the software. We'll take the line as normal. We'll draw the XY line first. We'll name here in the caps X and Y out here, VP and HP. We'll use the select tool to place the namings at the desired positions that we need. Now here the line is placed at a distance of 20 mm above HP and 30 mm in front of VP, as they have given in the questions 20 mm above and 30 mm in front of VP. So for that I'll change the line to reference line and I'll just randomly draw a line from this position till here. Same as from here till here, I'll draw another line. And later it says that 60 mm another line. So why I'm drawing this line is because I'll just specify the distance. Using the smart dimension tool, I will specify the distance out here. It is 17. Now I'll give the distance as 20, it will change. This changes because I have kept the maintain relationship on. Same as at the bottom also, we'll specify the distance as 30 mm. It changes. Now we have to draw another reference line which is at a height of 60 mm from the HP. So here if I give the dimension is 60 mm. Now before we start, I'll give the specify the point of starting here. This line has to be the visible normal, the normal line. We'll give the namings out here. This particular point is A and this particular point will be A dash for us. Same as here they have specified the distance between the end projectors. End projector is 70 mm. So I have to draw another line of 70 mm here. You can do it in two ways. Either draw a line of 70 mm first, enter, and then draw a connecting line using this method, and then trim the ends of the line out here and trim this line out and then give the dimension. This is how when the maintain relationship doesn't work for you, 70 mm distance, or else you can do this method in this method also. That is, I'll just slightly move that line out, or else I'll delete it and then I'll draw the line and I'll specify the distance now. See here, it is 62. I'll specify it as 70. It will change. See here, it will change the line. I will place the line here, point here, as it got shifted. We'll trim the ends of the line here, and this is the second method of drawing. Okay, now once we have completed, they have given the end projector distance as 70 mm. Now at the bottom position, they haven't specified till what distance the line is being kept. Okay, so for that what we are supposed to do is we'll take the line and first we'll draw the visible line out here, line, and it should be visible from here till here. Then we'll take the arc by center point, and from here till here we are going to draw the arc downwards, and then this particular line has to be normal. Change the line, select the line, normal line. From here project the line downwards straight. So till what extent are you going to draw the line straight downwards? So for that, as the distance between the end projector is 70 mm, here we had to specify the other distance, right? So they have given just 70 mm, but here to what extent the line will go is the second part. So here in the question they have forgotten to mention that the distance here at this particular point was 45 mm. So we are going to draw another reference line of 45 mm down here. We'll draw the line, we'll give the dimension now. Here the dimension is 45. Hit enter and it comes out here. And I will use another command of extend to next, so which actually projects the line forward. I'll change the line to visible, and now I'll connect the ends from here till here. Okay, the same process will repeat it again. So arc by center from this point to the tip of this and till here. So this particular thing will zoom it so that it is clearly visible. Now this line arc that we have drawn, it should be actually normal. We'll change it to normal. Then again we'll select the line. From here we'll project the line upwards until the upper line. Till here I'll draw it. Now we'll take the line as we have both the points. So we'll trim this particular excess line out here so that our line joins correctly. Now when we measure with the normal line from the tip of this line to the tip of this point, so both the lines should be same. As you can see, this length is 82.01, roughly around 82, and from here, and if I touch it here, you should get the same measurement. See here. Now you get it around 82.01 itself. Now we'll measure the distance and angles. Alpha here it is 29 degree, and sorry, that is not alpha, that is theta. Alpha is 30 degree. Here beta, we have beta here as 12 degree, and pi, this angle is pi and the other angle is theta. Here it is 11 degree, and we'll give the namings as well as the measurements. So we'll fit it. This is 82, the same length you get it for 82 here, and the true length is, so I took it twice. So if it doesn't click the straight line, make sure you click on the zoom it, and then place the dimension. So this particular line has to be measured. It is 80.69, a slight difference. Even here it is 71.59. We'll do the namings. A, we have it here. This is B, and this particular point becomes B dash, and here it is B1 dash, and this is B2. Once we have the namings, we'll place it at the right positions so that it represents the right point, and click on fit, and this actually completes our third problem.